Hi everyone, my name is Žiga. Here with me today is Žan. We're going to be holding a live coding session today. We come from Zerodays, a company situated here in Ljubljana, and we focus heavily on developing software for startups and AI. We're going to be showing something that we've built internally, we've used it, and then we decided to open source it since we found out that some other people might be interested. To start, let's start with the technologies that we'll be using. Firstly, we'll be coding using React Native. I know that not everybody here knows React, and not all of you might be fans of it, but yeah, we'll try to go slowly, step by step, explain things, but I'd like you to ask questions even in between the session, just to make sure that we get rid of the problems straight away. More specifically, we'll be coding within Expo, but that's just a layer on top of React Native. Then we'll be connecting to the OpenAI's models, more specifically GPT-4. We'll be presenting what we can do with our own package. It's called React Native Gen UI. It's published to NPM. But what does it do? Our package enables easy use of OpenAI's APIs on React Native. It supports streaming out of the box, and it supports generative UI. Let's take that each one step by step. So the most basic case of using a GPT-4 or a similar large language model on mobile would be to take a list of messages, send it to OpenAI via a simple REST call, and get the response in one huge bundle, then show that to the user. But we've gotten used to streaming. And on the web, that's easy. On React Native, there's not a lot of support for streaming. Only a few libraries even attempt that, and one of those is our library. Then the big thing here, generative UI. Let's split that into a couple of steps. So firstly, there were large language models that could deal with text. Then OpenAI introduced functions. Functions are something that developers can put in, make them available to the model so that the model can decide to call them or not. In this case, the user is asking what's the price of Ether in dollars. The model knows that there's a get Ether price function available to it. It decides to call it. That gets propagated right back to the device, and here the developer needs to handle what happens inside that function. We can call our favorite crypto API, get the price, and return it back to OpenAI. That's quite straightforward. The model can then, can we just go back? Yeah, thanks. The model can then comment upon this information. But those two things here are just data. Oops. they are not visible to the user. The user doesn't see that. That was the beginning of functions as we know them. Then Vercel, the huge hosting provider a lot of you already know, decided to build up on that idea. They decided that this data could be shown to the user as well. This should be done in an interactive way and should allow the models to communicate with the users with a richer, better text interface going beyond just simple words. So in this example, we get the price, but we also render this data, a chart of what the price looked through the history to the user so that the interface gets more intuitive. So today, we're going to build a weather chatbot in a similar manner. We're going to be demonstrating what our package does and how we can use it to easily build such a thing. Firstly, let's discuss a few things. The core of what our library provides is a use chat hook. Hooks in React are functions that wrap certain functionality within them for the developers to easily use them in their application. Our use chat hook manages the state of the chat, enables the streaming, and handles updates within the UI automatically. So what's the plan today? We'll be starting by implementing a basic chat interface, text-based, using our useChat hook. Then we'll add some tools, namely getWeather function, so that our weather bot will be able to retrieve the weather forecast from the internet. We'll then build upon that to present the data to the user in a better way, and then we'll even play something with managing loading states for the user, not to get bored while he's waiting. So now let's go to the VS Code. We've prepared the skeleton for this app, not to waste your time today. So we have a list of a chat list of messages. We've also implemented some of the input components to get the user's input and send it to the OpenAI. But firstly, here at the top, we see that we have one message defined saying that assistant, this is our model, GPT-4, is saying, hello, how can I help? This is hard-coded and does nothing in particular at the moment. Now let's write a useChat hook and see what it exposes. We can provide it our OpenAI instance. This allows it to call the OpenAI APIs and initial messages. Those can be whatever, but in this case, let's just say that assistant greets the user and says, how can I help you? From the useChat hook, at the top, you can see that we've unpacked the messages. There are a few things missing, but it exposes also the values of isLoading and isStreaming that will be useful later on to show the user what the state of the exchange is. Now we can uncomment the input section down below. We've unpacked some more values that the hook exposes, but that isn't really the core of it. And the input down here doesn't appear to be so fast after all. Well, okay, here it is. Okay, so we still have our messages list. Then there's an input allowing a user to type anything. So let's ask our weather bot, what's the weather like at the moment? Okay, the model doesn't know. That's because there's no ability for it to get up-to-date information. We all know that large language models were trained upon up to a certain point, and today's weather is not part of that. So now, let's add a tool definition to our useChat hook. We'll define a tool called getWeather, and it needs to have a few things. One of those is a description. This is the part that tells the model what does this tool do. In our case, it gets a weather for a certain location. Then we define the parameters. For parameter definitions, we use Zod. It's a library that validates data in runtime as well as provides us with the right types in TypeScript during compile time. Our getWeather function takes two things within an object. One of them is location, that's a string, can be anything. Then there's a date that defaults to now. There's just one thing left then, our render function. That's the function that will retrieve the data and give it to the model. We've of course already prepared a function to get weather from the internet. We pass it the location and fetch it. Then we return a single thing, the data. There's going to be no component, or rather we'll be returning an empty component. Okay. Yeah, we'll unpack current data in the forecast into two separate things for model to easily understand. Then we'll add an empty component, and we'll see how that works. So just to recap, in the middle of it, we have a tool called getWeather. We've added a description, what parameters it takes, and the render function that fetches the data and returns the data to the model. The user at this point doesn't see anything. Okay, so let's try it. What's the weather like? The model wants to know where we are. Let's tell him that we are in Ljubljana. Thinking hard, apparently. Okay, so what happened here is the tool was called. The user didn't see anything beyond just it's taking a bit longer. But then we can see here we've printed this can only be seen by the model. There's some JSON telling the model all the data that we returned there. And the model can then comment about that. It says there's 16 degrees Celsius, feels about right to me. But yeah, that's the basics. I believe most of you know that from trying the ChatGPT, the plugins, custom GPTs, and so on. Now the generative UI part. We'll add a component that will render this data in a way that the user will be able to see it and interact with it. Of course, we already prepared the component here. It takes the weather data, and we'll see how it works. Okay, let's try again. What's the weather like? Taking a lot of time again because it's happening, like in the background it's happening, like the model calls the tool calls the API on the internet. Then it returns both the data for the model to comment here and an interactive component showing the real data. This is already much better for the user. I believe users feel much more at home using this. But there's one more thing. While retrieving the data, there's some time that the user doesn't know what's happening. We can use a fancy programming concept here called yielding to yield a component before we start loading the data. So what happens is we'll yield some kind of loading animation, then we'll go retrieve the data, then we'll replace the actual component later on. Let's try again. Look for the loader in between of API calls. Okay, so here's the loader telling the user what's happening. Much better. Okay, perfect. So that might have been a bit much for everyone, except especially if you don't know React. So let's recap again. Žan, if you could take us just back to Figma, please. So we've implemented a basic chat using use chat hook. Then we've added a getWeather tool, presented the data, and then we showed the user a loading state when the data was fetching. The nice thing here is that we can yield multiple components. Imagine that we had a more complex use case. Imagine that we were firstly trying to locate the user using his on-device GPS. We could show an animation especially for pinpointing where on the earth you are. Then we could zoom into that location and tell him, now we're fetching the weather. That's an imaginary use case. But in a real world, there are usually some things that take a long time when dealing with large language models. One of those might be calling an assistant, calling agents to compute heavy things and so on. So we can show the user progress in between the calls. Okay, so that's our package. It's called React Native Gen UI. We'd like to invite everybody here to take a look at it, to play. It's published on NPM. There are also some examples, one of those being the one that we've showcased today. It's on GitHub. And that's all from our side. Now we'd like to invite you to ask some questions. No questions? Okay.
Sure, go on. Yeah, you mentioned that showing this visualization of weather data is done using generative AI. Can you tell us more? As I said, this was just magically done.
Yeah, so the components are coded by ourselves. This is not something an AI cannot output a valid React component on the fly. And even if it could, it would take quite some time. Those are components that are provided by the developers. This is just a simple example, but we could use that like to tell an AI, you can render charts here, you can do other things like images, you can show the search results from Google and work with me here. You could showcase different things. So what generative AI in this case means, and that's not our term, that's actually Vercel's terminology, is that an AI can go beyond just words into components, displaying the data visually rather than just writing things down.
Yes. Is this library that you built part of the Vercel one, or did you expand on it and add new ideas or fix something that was bothering you there? Since you said that for web there exists one.
Yeah, it's a port. There's a few problems with it. Firstly, it uses React server components, which is nowhere near ready on React Native at the moment. Then secondly, OpenAI itself, without any kind of UI, the OpenAI library does not support React Native at the moment. So we've had to implement all of that too. So to answer your question, it actually does not call any functions from those libraries, but it expands on their typing definitions to make sure all things are compatible and up to date.
Okay.
Can you maybe tell us any real-life scenarios where you use this?
I'm not sure I can talk about most of them, but we at zerodays work a lot with the Astra AI team, and there an OpenAI model tries to help to tutor students to learn math. And one of the things that is needed in this case is to render a chart. Those charts are like, when we started, there was no good way to do it. Now there is, Vercel made it, but we're going to be porting Astra to mobile probably, and that's one use case where we're going to use exactly that. Okay, whichever. Okay.
Yeah, so I want to first, you showed us how this generative API works with weather data. And you mentioned some other use cases. Does it expect some kind of a format for any third-party tool or library when you needed to set it up? Like, for example, there are some specified libraries to work with some specific data, like, I don't know, traffic data or cryptocurrency data, which needs maybe some additional setup than simply connecting with API key. How flexible your package is?
So the execution of this function that we have here, this being render function, is completely handled at our side. So you could do anything that you could do in TypeScript here. I hope I understood you correctly. So whatever you return here as data will be visible to the model. Whatever you return here as a component will be visible to the user. Meaning, you could return anything. The model doesn't care. It receives JSON. But if you just stream huge amounts of data points from Ether history, price history, that might be confusing for it. It's usually better to to go through data to extract the features you are interested in, and give that to the model, like very similar to what you would do to the user. You don't like push huge amounts of JSON to them. You transform it into a way that the user can understand. So that's one side of it. The other is those parameters are defined here for the model to know how to call our function. The model does get that sometimes wrong, and that's expected. There's some documentation on the OpenAI's website on how to deal with it. But within our library, since this is defined in a type-safe manner, those arguments that the render function then receives are fully type-safe. So if you hover, if we do that, location is a string for us, date is a date, and so on. So there's type safety there if that's what you were asking to.
Got it. When I looked at the presentation that you had, there's a sketch that you did with on the left side it was API, your favorite API, and right side was your library. So I was under the impression that the library needs some kind of a setup with that API. But if I understood you correctly, it simply understands the output.
Let me just go back to
here. Here.
Okay,
right.
so yeah.
So my question is, do you need to connect this API with your library somehow, or it's simply with the output?
It's this red part. Everything in red is completely handled on the library user side. Okay, there was one other question, I believe. Yeah?
An easy one or a hard one?
Let's go for both.
Okay. So you have developed a library which is simplifying the communication with OpenAI. If I'm using your library, how can I be sure that I'm actually talking with OpenAI and not with some hacker or somebody else?
Yeah, that's a great question. Firstly, it's open source, of course, and you know what you're using. I know that not everybody delves into the code always, but you can. Then secondly, doing it exactly like this in production is a bad idea. It's extremely bad idea, because this means that you're exposing an OpenAI API key on the device. That's not good. In real life, there needs to be a server in the middle of it handling the sensitive information. That's usually an API key and maybe your system prompt being like, the magic that your prompt engineers did and so on. But our library supports that. So what you would need to do is, we don't provide that because we don't know what users will be using on the backend. But what you could do is just forward server sent events via your server. You don't have to expose that data, and it's relatively easy. And it's the same like Vercel does everywhere else. So I hope this answers what you were asking.
Yeah.
Was that the hard one or the easy one?
We can figure out something something more complex. We can also dive into the details here. I could ask a couple of complex sub questions, but let's not go into that.
Sure. Maybe we can talk after the presentations are done. Okay. Sure, go on.
So you mentioned streaming in the beginning. Did I miss something? Where is the streaming part?
Okay, so it would be rather easy to just have a post request to the OpenAI, then get the data back. It's not actually that hard, but there's no support for it on React Native for some reason. And the streaming is done, the streaming here being, the continuation of text as it gets written, being streamed directly to the device. OpenAI does that using server sent events. It's not very hard, but then our hook in the background, calculates what the new message is always, appends. Seems easy, though there are some function calls and those things that you have to then think a bit more about, but it's nothing magical.
Thanks.
Sure, go on.
I might be repeating my colleagues with their questions before. I'm a complete noob at JavaScript and React, so I might have missed what you actually did in the presentation. So you live coded, let's say, the UI components, so the weather, display, and loading state-ish.
In the skeleton for the application,
Yeah.
that meaning that being the chat bubbles, the list, the input here, and those actual components for the weather, those were coded in advance. That would take quite some time.
Yeah.
We've just used them to display how we can use this use chat hook. All of this is modular. You can change any of it. This is just one use case, us rendering it in such a way.
I'm trying to understand what the library does and what you did with live. So let's say you live coded the UI and the library, you coded also the bindings so that the library can understand how to use them, right?
Yeah, so there's actually there are actually four main things that this library does.
Okay.
First is that you don't have to deal with actual web requests,
Okay.
but that's rather easy. Then there's streaming. Again, nothing huge, but it has to be done somehow, and there are almost no other libraries supporting it. Then there are the tool definitions. I don't believe there's a library on React Native that does it in such an easy manner. There is for the web by Vercel, that's why we are porting it here. Mm-hmm. It's much harder otherwise. And there's the third thing, all of this is type safe. Some of you like types, some of you don't, but for us, being type safe here is extremely important. Having it defined in that way ensures that we have data in a form that we want it to. Then maybe that might be delving into the complex part a bit, but you might see that this function is actually a function with a star. This means that this is a generator function that doesn't return just a single result, but can yield multiple results. So the actual, the nice bit for the users of our library here is that we manage the state internally, allowing you to yield multiple loading states, multiple intermediate states, and only then return the data. That would be like the gist of it, I believe.
So if I wanted to, let's say, for example, extend the example application. Let's say I wanted to answer where can I find parking near me right now. I would need to code the map component probably.
Yeah.
And tell the AI how to get the parking information from somewhere.
Yeah, you would write a get empty parking spaces tool here.
Yeah.
Tell it, what the parameters does it take. Maybe how big of a car you have. Do you need the wider spaces? Are you looking for a motorcycle or something? And then you would have to code this part, fetching of the data. So I suppose you have a server that knows how to find parking spots around a certain location. Then you could render those on the map and show that to the model as well. You could say the nearest 3 parking spaces are, and the coordinates. So the model would know how to take you there.
And I assume from the description, the AI knows that it can use my tool if I ask it something in the ballpark of I need parking.
Yeah.
It will know how to connect my tool to my request-ish.
Yeah, it should. It always works until it doesn't. So that's on the OpenAI. The GPT-4 model is very good at this, but yeah, you have to, that's part of the prompt engineering here. You usually have a system prompt giving instructions to the model. Then the description here and the parameters are also, and the name, are also kind of a part of this prompt engineering, getting the model to know when to call a certain function reliably.
All right, thanks.
Okay. So if we get maybe a little bit hectic, if I have multiple tools that are fetching parking info, it would be confused which one to use.
Yeah.
If I'm only using a description and parameter, right?
Yeah, it would get confused. But an analogy I'd like to make here is I'd get confused too. if you put me in a black box, say like, here are 7 functions doing the same thing with relatively similar names, I don't know. So yeah, prompt engineering is, you know, a soft kind of skill, you know, getting people and models to behave like you want them to.
Sure, that makes sense.
Is that all?
Okay. I think
Okay,
that's all. Yeah.
perfect.
Thanks.
Thank you all for your attention.